All right, welcome back. Now we're going to do a ChkPt6. And again, what I want you to do is write this down, push pause, and I want you to verify this identity. Okay, and then come back and see if you got the same answer that I got. Okay, and again, remember there's more than one way to do these. Just see if you got the same answer. Okay, or if you were able to show it. Okay, here we go. I'm going to start with this side. I'm going to start with the left side. So we're going to do tangent squared theta over 1 plus secant theta. And again, I'm going to use the Pythagorean identity because I've got a secant down here. Okay? And let's do that. So tangent squared theta. So again, what do we know about the Pythagorean identity? So I got to think about it. Maybe you do too. So we've got tangent, right? So that means we're going to get tangent squared theta plus 1 equals secant squared theta, which means then this has to equal on the top is secant minus 1. So secant squared theta minus 1. And then of course we get 1 plus secant theta. And then again, you want to look for opportunities to factor here. So in this case here, I've got a 1 plus secant theta. I can use that this is a difference of two squares, right? So I'm going to rewrite this and factor the top. So that's going to give me secant squared theta plus 1 times secant squared theta minus 1 over 1 plus secant theta. And of course, these are going to cancel. Oh, I put a squared up here. These are not squared. Sorry. It's secant theta plus 1 times the quantity secant theta minus 1. So the secant theta plus 1 is going to cancel with on the top of the bottom. And that gives me secant theta minus 1. Okay, now, I'm going to do it a little differently. Instead of now doing this side and seeing if I can get the same thing, right, which you can, I'm going to look at this and say, okay, I need a cosine on the bottom. So I'm going to try to get a cosine on the bottom here. So what I'm going to do is this is going to equal what? 1 over cosine minus 1. Right? So now all I have to do is multiply the top and the bottom by cosine to get a common denominator. So this will become 1 over cosine theta minus cosine theta over cosine theta, which is equal to, now I'm going to combine the fractions, and into one fraction I get 1 minus cosine theta over cosine theta, which is exactly what the goal was. Now, so I did it in one long string of equals, but there's nothing wrong with taking this side and going to here and taking this side and making it go to here, right? Just like I did in the last one. Again, different ways to solve it.